Welcome to Network Analysis online series, and today let us discuss about electric current and what is current source, what are the various types of current sources, all these things. Okay, so first one is electric current. Yes, we know that electric current is the flow of charge or flow of free electrons. Yes, why can't we say the flow of electron is current? Because, so if suppose if we observe the structure of the atom, and here this is called nucleus, so which contains protons and neutrons, and here this is orbit. In the orbit we may have the electrons, and these electrons are also called extra nucleus. These electrons are also called the extra nucleus. And electron, so which is very far from this point, is called the free electron, because it contains low energy, hence ready to jump from this atom to another atom. When atom lose the electron, then it becomes the ion. Ion is called the basic charge. Ion is the basic charge. Suppose if molecule lose the electron, then it becomes the positive ion. If molecule gains the electron, then it becomes the negative ion. So this is the charge. Okay. So now according to the current definition, the flow of free electrons is called current. So because the ordinary electron cannot move, it is having some much energy, therefore it is unable to move from one atom to another atom. Only free electron can move from one atom to another atom. So hence here I can say the flow of free electrons is called current, or you can also say the rate of change of charge is called current. So that is I is equal to dq by dt. I is equal to dq by dt. So dq by dt stands for rate of change of charge. Suppose for example, case 1. In one circuit, the value of charge changed from one value to the another value without change in time. That is, in one circuit, the charge changed suddenly. Then what happened in the sense? The charge Q is changed from Q1 to Q2. So without change in time, that is, change in time is 0. Then what is the current? I is equal to Q. Let it be, this value is some Q like that I assume. Then it is Q by 0. So which is infinity. Or we can also say maximum. Thus, in which circuit the current is maximum? In short circuit only, the current is maximum. As in the short circuit, the current is maximum, we can also get some characteristics of the short circuit. That is, first characteristic of the short circuit is, in the short circuit, the change of charge occurs suddenly. And second one is, in the short circuit, the value of current is maximum. And third characteristic is, in the short circuit, the value of resistance is minimum. Why resistance is minimum? If resistance is minimum, then only that body allows the maximum current. Otherwise, it is not possible. Otherwise, it is not possible. So therefore, what you can say, in order to allow the maximum current, the resistance will be minimum, and here the charge has to change suddenly. Okay. Next, this is first one. And second one is yes. In circuit, the charge is to be considered as stationary. That means there is no change in the charge. If the charge is not changed, we can say dq is equal to 0 when dt is equal to some finite value. Some finite value. So then, what is the value of current? I is equal to 0 by t. This is equal to 0 amperes. Yes, 0 amperes in the sense that circuit is open circuit. In open circuit, yes, the characteristic of open circuit is, in open circuit, the value of current is 0. Next, the change in charge is 0. Value of current is 0. Next, second one is change in charge is 0. But the value of resistance is infinity. As there is infinite opposition force is there for the current, so hence the current is 0. The current cannot flow. Okay. And third category, third case is, if suppose the change in charge is Q and change in time is T. Change in charge is Q and change in time is T. Then what is I? I is equal to Q by T. I is equal to Q by T. So now we know that the unit of current is ampere and unit of charge is coulombs and unit of time is seconds. So hence we can write 1 ampere is equal to 1 coulomb per second. 1 ampere is equal to 1 coulomb per second. Okay. Next. Now let us see what are the properties of current. Properties of current. Properties of current. The first one is the current never reverse. Current never reverse. Suppose for example, let us assume like this. This is one switchboard. This we have this switch, and for this switch I have connected this source like this, and here this will be connected like this. So much length of wire is connected in this fashion. For example, let us assume. Now, when switch is closed, at t is equal to 0 seconds, I close the switch at t is equal to 0. Then some amount of current has to be flowed like this. So amount of current is flowing like this. And after some time, that means after some time, in the sense I did not give much delay. So that is, just I have taken t is equal to 0 plus 1. Immediately again I open the switch. Just to see here, at t is equal to 0 second, the switch is closed, and t is equal to 0 plus, immediately after the switch is open. Then what is the status of the current? Yes, what is the status of the current? That means we assume that, so when switch is closed at t is equal to 0, the current will be started like this. But when switch is open, the same amount of current after some duration, this will go in this fashion like this. It is wrong. It is wrong. So the current never reverses. That means if in between A and B the current flows like this, 5 amperes. I is equal to 5 amperes. Just let me assume. If suppose this is B and A, if it is 5 amperes, then I used to write this as I is equal to minus 5 amperes. Minus 5 amperes. So what is the meaning of minus 5? We are assuming that the current flows from B to A. This is only assumption. This is only assumption. We cannot say the current flows from B to A. Once the current flows from A to B is 5 amps, that is final. We should not say minus 5. So why we are telling minus 5 in the sense, in the problem, in the theoretical calculations, this situation may be arised. So in such cases, we consider I is equal to minus 5. I is equal to minus 5 in the sense it is not the meaning of the current flows in the reverse direction. Current flows in reverse direction. Okay, this is wrong assumption. This is our wrong assumption. Next, the second property is, according to the definition, the current is flow of charge is called current. The charge may be either positive charge or negative charge or both. But the direction of current is always along the direction of positive charge and it is opposite to the negative charge. Yes, for example, let me take one network. This is one network. Let me take this is point A and here it is point B. This network contains both positive charge, negative charge, positive charge, negative charge, like this. Several charge combinations are there. Several charge combinations are there. Thus, when the positive charge moves from A to B, then the current is positive. Current I is positive. That is IAB is positive. Okay. So when the positive charge moves from B to A, then IBA is positive. IBA is positive. That means I should say the direction of current, whether it is positive or negative, based on the movement of the positive charge only. Yes. Suppose for example, in one competitive examination, he asked the problem like this. What is the problem in the sense? He has given the same network and he has given the data like this. For the network as shown in figure, the positive charge moves from A to B. Positive charge moves from A to B at the rate of 5 coulombs per second. And negative charge moves from B to A at the rate of 3 coulombs per second. So then, how much current flowing from A to B, or how much current passing from A to B? So that is, you need to find what is IAB. This is the problem. Then what is the solution for this problem? Yes, what is the solution for this problem? If you see here, when positive charge flows, it is associated with the current. When negative charge flows, it is also associated with the current. That is, due to the movement of positive charge, the current is 5 amperes. Due to the movement of negative charge, the current is 3 amperes. Then what is the total current? The total current is 8 amperes. So, but here he asked to find AB. That is the current flowing from A to B. So then it is as in the direction of positive charge. So hence I consider this as plus 8 ampere. Just to see here, I positive is 5 amperes and I negative is 3 amperes. I total is, need to add both, 8 amperes. Yes, as he asked to find the current from A to B, and from A to B the positive charge is moving, therefore IAB is 8 amps. Then what is IBA? IBA is minus 8 amperes. IBA is minus 8 amperes. Yeah, this is the second property. Okay, next, third property. Yes, third property. When elements are connected in series, the current flowing through each element is same. For example, I have the two elements. This is element 1 and this is element 2. These two are connected in series. Let me assume these two are the two resistors of resistances R1 and R2. So when I assume the current flowing through the R1 is I1, current flowing through R2 is I2, we can say I1 must be equal to I2. Let it be, this is some value I. That is some value I. Yes. One time he asked one question in one competitive examination. What is that question? In the sense, he has given the network like this. This is 3 amperes and here it is 2 amperes and here he connect one resistor, it is 1 ampere like this. 1 ampere like this. Sorry, 1 ohms like this. Sorry. Then how much current passing through the 1 ohm resistor? How much current passing through 1 ohm resistor? Yes, he has given the options like this. That is, those options are 3 amperes, 2 amperes, 5 amperes, 1 amperes. Yes, which is the right answer? Tell me. Which is the right answer here? Our statement is, when elements are connected in series, the current flowing through each element is same. But here it is not like this. This is 3 amperes and this is 2 amperes. Then how much current flowing through the 1 amperes? Thus, as this problem is not obeying the property of current, therefore we can say here the current is 0. And we can also say this circuit is wrong. So hence I will pose one more option, it is 0 or not possible. Not possible. Okay, next. Suppose for example, I will give one more example. Suppose for example, I have the circuit like this. This is 3 amperes and here also 3 amperes. This is the resistor of resistance 5 ohms. Now the question is, how much current flowing through the 5 ohms? How much current flowing through the 5 ohms? So generally we assume that this is 3 amps, this is 3 amps, so hence the current passing through the 5 ohms is 3 amps only, like that. According to the property of current, that is, when elements are connected in series, then the current passing through each element is same. But in this problem, if you observe this current source is connected in this direction and this current source is connected in this direction. Both current sources are opposing each other in the series. So hence, so now this is also not properly or not obeying the property of current. So hence, here also the current will be 0, or this circuit is wrong. This circuit is wrong. Okay? Yes, next. The fourth property is when elements are connected in parallel, the current will be divided. Yes, when elements are connected in parallel, that is, for example, this is one current source and it is another current source. These two are connected in parallel. Let it be I1 and here it is I2. This is A and B. Then how much current passing here? Here I is equal to I1 plus I2. I is equal to I1 plus I2. So this is how we can say when elements are connected in parallel, the current is divisible. So now let us see the current source. Current source. Yes, what do you mean by electric current? Electric current is the flow of free electrons or flow of charge or rate of change of charge is called current. Then what is current source in the sense? It is the source of energy in the form of electric current. It is the source of energy in the form of electric current. And here there are various types of electric current sources are there. Those are, the first classification is ideal and practical current source. Ideal and practical current source. Next, second one is dependent and independent current source. Dependent and independent current source. And other than this we have AC, DC like this. We have also AC and DC like this. But here I concentrate in these four categories. Yes, first let me take ideal current source and practical current source. That is ideal current source, practical current source. Yes, before going to this topic, I want to tell one real-time experience of you or me. Suppose when we are traveling on the road, we used to stop at the signal whenever we observe the red bulb. If suppose one beggar came to us, he asked, "Sir, could you give me 10 rupees? And I have 30 rupees in my pocket." Immediately I received the call from my home that, so while you are coming to the home, bring one milk packet. The cost of milk packet is 25 rupees. Yes, I have 30 rupees. The cost of milk is 25 rupees. Cost of milk is 25 rupees. Then how much amount of money I can give to the beggar? That is, I can able to give 5 rupees only. 5 rupees only. But his requirement is 10 rupees. Here I am satisfying him with the 5 rupees only. Here I am the source. Here I am the source. Next, another day, so the same beggar came to me and asked, request for 10 rupees. And at this time, So I have the 100 rupees. At this time I have the 100 rupees. So hence I am able to give the 10 rupees to the beggar. And this time also I am the source. Now what is the difference between this type of source and this type of source? Yes, what is this kind of source? I have the 30 rupees, but I am unable to give the 10 rupees. And here I have the 100 rupees, I am able to give the 10 rupees. I am able to give the 10 rupees. Because in the first case, my internal requirement is there. So hence, any source first to fulfill the requirement internally. Then only it can see the external requirements. Okay, so as there is no internal requirements here, so hence it is very easy to give 10 rupees to the beggar in the second case. So here, this is the practical case and this is the ideal case. This is ideal case. So hence what we can say? Ideal current source in the sense, the current source which does not have the internal current requirement, such current source is called the ideal current source. Then what is practical current source? The current source which have the internal current requirement, then such current source is called the practical current source. So that is the first point here I used to write as ideal current source in the sense in which internal current requirement is 0. Internal current requirement is 0. But here internal current requirement is finite. Internal current requirement is finite. Next, second case is, I used to represent ideal current source like this. This is the representation of ideal current source. Okay. Next, in practical current source in the sense, the current source which is connected in parallel to the resistor. It is R internal, says IS, and here it is I internal. So therefore, it cannot able to give the IS as it is to the AB network. It can give only the value of I, which is equal to IS minus I internal. IS minus I internal. Next. Third point is, in ideal current source, the value of resistance is, internal resistance is infinity, because this is open circuited. Internal resistance is infinity. But whereas in the case of practical current source, the internal resistance value is finite. Internal resistance value is finite. Next, fourth one is, if I want to draw the characteristics between, this is the current which I can consider as the I versus load. I versus load. So irrespective of the load, the value of I is constant, that is IS only. IS only. But whereas in the case of practical condition, so this is load and here it is I. So actually it has to be IS. But as the load is increases, the IS value is decreasing, because I internal is increasing. So hence this will be like this. And before this point, that is during this, what happened? IS is greater than I internal. Next, at this point, IS is equal to I internal. And at this point, IS is less than I internal. Yes, this is about ideal current source and practical current source.